This LeetCode problem asks us to return the index of two numbers within this array that sum to a given target. We'll start with the brute force naive implementation where we simply check every possible combination of numbers and then we will optimize it. So for int I equals 0, I is less than nums.size, I plus plus. Now I is bound to every possible index, and for each of those possible indexes, we'll check every other. So for int j equals 0, j is less than nums.size, j plus plus. Now I and j are bound to every possible pair of indices, but they may also be the same number. So we need to eliminate that case by saying if I is not equal to j. Now if nums of I plus nums of j is the target, then we can return I, j, just like that. However, a compiler will not like this solution because when a return value follows a conditional, it does not know that we're going to return, even though we're guaranteeing a return value right here. So we'll have to say return -1, -1 if all else fails. Now, you'll see that this implementation works fine. However, the runtime is n squared, and we can actually do much better. The first optimization we can make is by setting j equal to I plus 1, because we only need to test the cases where j is greater than I, because any situation where I is greater than j is just the mirror image of j being greater than I, and so we can actually eliminate half of these possibilities. Now we know that I will never equal j, and we can eliminate this condition. And our new runtime is n squared over 2. However, this is still order n squared because asymptotic complexity ignores constant factors. Now we can actually do much better. We can have a linear or an order n algorithm by taking advantage of the fact that every time you find a number in this list, you know that if in the future you find target minus that number, that means you just found a combination that satisfies the criteria. So we'll use our unordered map. Now, the unordered map will map an integer, being the number we're looking for, to its index, which is another integer, and we'll call it m. The unordered map is a great tool because it has constant access time, and it hardly will affect the runtime of your algorithms. However, it does take up memory. So this is now order n memory, whereas before it was constant memory because we were not storing anything. However, the unordered map has constant access time. Any sort of ordered map will have logarithmic access time. So when possible, unordered maps will help your runtime. Now, for int I equals 0, I is less than nums.size, I plus plus, we'll say if m.find nums of I not equal to m.end. Now, this is just a long-winded way of saying if m does not contain, if m contains nums of I, the contains operation was not added until C++17, and as you can see, this is C++13, I believe. So this is how you say if you can find nums of I, then we'll simply return I and the map's value for I. Or, excuse me, the map's value for nums of I. Now, the other condition is where we're going to have to add a value to this map. So we'll just say m of target minus nums of I equals I. And if we run this, everything passes, and we will submit it to check how our solution stacks up against the rest. As you can see, this is one of the fastest solutions out there. However, there can be solutions with better memory because you don't need to store anything, but you're sacrificing runtime. There's often a balance where you have to decide how much memory and how much time you want to spend because you will have to make a compromise. Thank you for watching. Please subscribe for more videos.